NASA's Voyager 1 spacecraft, the longest spacecraft ever launched, continues its incredible journey through space. For nearly 50 years, Voyager 1 has transmitted vital information from the far reaches of the universe, greatly advancing our understanding of the universe. However, recent releases from this amazing spacecraft have produced confusing signals that have left the entire space community in awe and confusion. The signs have sparked debate as to whether they are due to a technical error or indicate something more remarkable, such as terrestrial activity. Join us as we dive deep into the mysteries surrounding these amazing transitions and discover what's hiding in deep space. Man's fascination with the mysteries beyond our universe has driven space exploration since its inception. This insatiable curiosity led to the early launches of missions such as Explorer 1 and Explorer 2, which were among the most ambitious space missions of their time. The launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Just 14 days later, on September 5, Explorer 1 followed, setting the scene for a journey unlike any other. The two spacecraft, each weighing about 720 kilograms, about the size of a small car, were launched in the rare event that the outer planets play a significant role in their orbits and result of the mission. These spacecraft traveled in different directions and at different speeds during their amazing journey. A significant moment occurred on December 15, 1977, when Explorer 1 lost its orbit due to a difference in orbits. Since then, Voyager 1 has emerged as an invaluable resource, providing invaluable information that has changed our understanding of the universe and its many facets. Before diving into Voyager 1's latest amazing discovery, which has captivated the entire space community, let's recap some of its most famous achievements. In 1978, Voyager 1 came within 265 million kilometers of Earth during its Jovian imaging mission. By January 1979, he had begun a 100-hour process recording a composite video of Jupiter's orbit. This collection of 3,750 images provides a historical overview of Jupiter's dynamic atmosphere and its complex features. The spacecraft's discoveries, including the discovery of a small ring around Jupiter and two previously unknown moons, greatly increased our understanding of the gas giant's complex system. Repairs were made to keep the spacecraft safe and avoid a collision with Titan, one of Saturn's moons. After the successful mission to Saturn, scientists decided to end the Voyager 1 and Voyager 2 mission. However, the spacecraft was launched on a new route beyond the borders of the solar system, traveling at a speed of 325 million kilometers per year. In January 1990, Voyager 1 began its interstellar mission and continued its celestial journey. During this time, Voyager 1 made important discoveries, including the identification of 4 other moons, Mimas, Enceladus, Tethys, and Rhea, and captured some of the most famous images of the solar system. On February 14, 1990, Voyager 1, about 6 billion kilometers from the Sun, began a video tour called Family Portrait, capturing images wonder of the planets of the universe. This set of 60 images added to Voyager 1's collection of 670 images taken during the Neptune impact. Voyager 2 also achieved major milestones during the mission. As it approached Neptune, it recorded a wind speed of more than 13,100 meters per second, the fastest known wind in the solar system. The achievement was to identify Neptune's atmosphere and its largest moon, Triton. Triton's surface temperature drops to minus 391 degrees Fahrenheit, making it one of the coldest places in the solar system. Triton also displayed unique features, including ice volcanoes that emit nitrogen gas and push ice particles 5 kilometers into the atmosphere. These remarkable discoveries have deepened our understanding of the diverse and complex nature of celestial bodies in the outer regions of the solar system. Voyager's work has had profound and transformative results. Voyager 1 and Voyager 2 have shown that the moons of Jupiter and Saturn, once thought to be very dark and inactive, are still covered in natural activity. Voyager 2 achieved many milestones, including being the first to transit Uranus and Neptune, the only spacecraft to do so. NASA has used many strategies to extend the life of these spacecraft, including turning off heaters and unnecessary systems to conserve energy. The project ends in 2030, a moment of pride and sadness for the scientists and engineers dedicated to this amazing work. The design of Voyager 1 and Voyager 2 is amazing. These spacecraft were designed as stable platforms that rotate at a speed more than 15 times slower than the clock. This design choice reduced the field of view when the spacecraft was traveling through space. Even before reaching the outer planets, the spacecraft began returning images of Jupiter, showing swirling clouds and prominent features. The Great Red Spot, a giant storm on Jupiter, held an audience at NASA's Jet Propulsion Laboratory. However, most of the attention, active volcanoes are found on Jupiter's moon Io. The spacecraft's instruments detected unusual signals from Io, confirmed by unique images showing tall volcanic columns and a surface scarred by eruptions. One of the most famous volcanoes, Au, erupted 10 times as powerful as Mount St.As. The spacecraft continued. Their cameras were eventually turned off to conserve power and memory before entering interstellar space. It should be noted that the images they took do not include Mercury and Mars for some reason. In addition to the Explorer probes, NASA has launched other popular spacecraft, including Voyager 10, Voyager 11, and New Horizons. The success of Voyager's missions was made possible by a variety of innovative techniques, including the high-energy efficiency of the spacecraft. These operations are essential to guide the spacecraft to distant locations and collect important data. The spacecraft was not only dependent on its propulsion systems, but also on the powerful aids to reach its targets. Imagine two bold rockets moving smoothly through our local planetary system, using the gravitational pull of the planets to propel them forward. This dance of the sky allows them to save fuel and achieve the necessary speeds to visit different places. Gravity's auxiliary function is to provide a small amount of gravitational force to the spacecraft in a very precise time. For example, when Voyager 1 was approaching Jupiter, the gravitational pull of the planet accelerated the spacecraft and accelerated it. Achieving that right is very important. Deviating from the correct angle or speed can have negative consequences. Despite the precision required, the brilliant minds behind these missions have successfully performed these ground-assisted missions many times, sending the spacecraft on an amazing journey. The great journey was made possible by these celestial missions, and Voyager 2 saw the help of Jupiter and Saturn to reach Uranus and Neptune. The success of Voyager's mission is due to these fundamental contributions. As we reflect on the incredible journey of these pioneering spacecraft and the wealth of knowledge they have provided, we look forward to new information on the Voyager 1 mishap investigation. Voyager 1 and Voyager 2 continue their mission beyond the boundaries of Earth, and their achievements include the study of Jupiter and its moons, Saturn and its moons, Uranus and Neptune. Time-lapse images by Voyager 1 show Jupiter's 10 revolutions in vivid detail, including the discovery of new moons and a small ring. These findings have greatly increased our understanding of the complex client system. Voyager 1 also discovered 4 other moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and took stunning images of Saturn and its rings, providing new insights into Saturn's complex system. The spacecraft made history by visiting Uranus and Neptune, providing invaluable information about their atmospheres and moons, and enriching our understanding of the outer reaches of the solar system. After completing their planetary missions, Voyager 1 and Voyager 2 will enter interstellar space and collect data on the planetary environment. This exploration continues to expand our knowledge of the universe beyond our solar system. As we await more information about Voyager 1's new signals and their potential implications for our understanding of the universe, the spacecraft's remarkable journey continues to be a source of inspiration for scientists and space enthusiasts. Their remarkable achievements continue to push the boundaries of human knowledge and exploration and demonstrate the limitless potential of space exploration. The Voyager missions have provided a wealth of information about the solar system and beyond. In addition to the famous images and data, the spacecraft will also carry the Golden Record, a special artifact designed to transmit the history of our planet to aliens. This album contains selected sounds and images to illustrate the diversity of life and culture on Earth. It includes greetings in 55 languages, songs from different cultures, and a collection of natural sounds such as thunder and whale songs. This message in a bottle, so to speak, expresses the hope that one day, if intelligent life exists elsewhere, it may be discovered, understood, and seen in nature. Of man. Voyager 1 and Voyager 2 were equipped with scientific instruments that have revolutionized our understanding. These devices include magnetometers, plasma detectors, X-ray sensors, and ultraviolet sensors. They provided valuable data on the magnetic fields, atmosphere, and particles observed during the spacecraft's journey. These instruments allowed scientists to measure cosmic rays, which are energetic particles that come from distant stars and other sources in the sky. By studying these cosmic rays, scientists can understand the dynamics of our galaxy and the nature of interstellar space. These ancient spacecraft continue to transmit data from the far reaches of our solar system. Their longevity and achievements are a testament to human ingenuity and perseverance. As they move beyond Earth, Voyager 1 and Voyager 2 push the boundaries of human understanding and continue to uncover the mysteries of the universe. Voyager 1 has already entered the interstellar region, the space between stars, where it encounters another environment full of charged particles from distant stars. The mission allowed scientists to study how the solar wind interacts with the interstellar atmosphere. In fact, in August 2012, Voyager 1 became the first human-made object to leave the heliosphere. The bubble of space influenced by the Sun. Voyager 2 followed in November 2018.